Helps if the mic's on. All right. Hey, continuing our talk on cells, we're going to take a break from memorizing cell parts, though, and actually get into some more of the concepts, and in particular, how things travel into and out of the cell membrane. All right. Now, this is going to be, that's how your cells interact with your body. Either they're creating substances to share into your bloodstream, maybe they're absorbing energy and nutrients. Maybe they're giving off waste products. All of the cell's functions rely on being able to transport the necessary materials, molecules, elements, ions, etc., back and forth across the cell membrane. So we're going to spend a few days talking about how that works. So the cell membrane, and we're going to talk mainly these first couple of days about some almost more like chemistry and physics terms. All right. We need to talk about how particles move, and so that's going to be a lot of chem stuff, a lot of physics stuff. So step one is going to be passive transport. Okay, so passive transport occurs without any energy being used. I always think of like air fresheners you'd have in the bathroom. They all they're highly packed with these scented particles. There's tons of particles in there. All you need to do is just open up a little hole in the top, and particles come shooting out of there. All right, so they're passively moving from high concentrations to low concentrations without energy being used. Types of passive transport. We'll get into all of these, but today is just about diffusion. Facilitated diffusion and osmosis are also terms. You've probably heard of all three of those at some point in time. Diffusion. So diffusion is going to be the movement of particles from high concentration to low concentration. All right, just particles do not like to stay closely packed to one another. All right, and we're talking about fluids here. We're talking about liquids and gases. Now, if you're a solid, you don't have a lot of choice in how close you stay to one another. But for fluids, they tend to want to spread out. Okay, and then within that fluid, molecules, ions, etc., they want to spread out from each other in there too. That difference in concentration. So, I said when I go from a highly concentrated area to a less concentrated area, that is called a concentration gradient. Right, so the difference in concentration is called a concentration gradient. And so when one area is more highly concentrated than the other, they're going to naturally move to that area. I always think about like crowds too, or like school. Right, we pack you guys in tight for in-person learning in classrooms. Then the minute the bell rings and we release you, you guys spread out away from each other as you're going in there. So these particles will continue to move until an equilibrium is reached. What's equilibrium, you ask? Hey, all right. Equilibrium, next vocab term, is achieved when concentrations through a substance are equal. All right, so when those particles, whatever we're looking at, are evenly spaced out, then the movement will slow down. It's not going to stop, but it's achieved at equilibrium status. Think about this one. Same thing with air fresheners. You're going to spray that air freshener. It's going to be really, this area is going to smell like scented whatever at the start. And it's going to keep spreading out until it fills the whole room. Or maybe you're, making Kool-Aid and you have a pitcher of water and you pour in the Kool-Aid packet, and those Kool-Aid molecules are going to spread out until they reach that equilibrium or kind of that homogeneous state in there. All right, so diffusion and equilibrium today. So if we have a concentration like this, I'll use drawings like this quite a bit. All right, the left is showing a highly concentrated area, the right showing a less concentrated area. Notice it's a membrane that things can go through. So this one's pretty easy. Particles are going to tend to want to spread out. So they're going to move over to the other side until we reach some kind of equilibrium. And nice, it's not solid, so they're going to keep moving, but the net movement will remain the same. Let me just double check. Nope, that's tomorrow. All right. Hey, that is it for the start of our cell membrane stuff. Didn't even talk about cell membrane, but there is diffusion, passive transport, and equilibrium today.